Howdy, everyone. I'm Daniel. We're going to get started in a minute. Just in case you want to know you're in the right place, this is the Allspice presentation about SVN and Git. I'm going to put a timer on the clock for about 2 minutes. We're going to let people still filter in. I'm coming in from Chicago. Beautiful gray skies here. Anyone want to, in chat, want to let us know where you're from or what it's like over there? Really happy to be here. Got a lot of interest for people who are using SVN. What I'd be curious about is if anyone in the chat has experience using Git already or is already migrated from Git or SVN to Git or vice versa. I'd also be interested if anyone in chat has some questions about Git or SVN. Fill them in the chat now. It would be really great. It's all private, so don't worry about other people seeing what you have to write. We're also going to be handing out lots of good documentation about the process. So a couple times during the presentation, I'm going to say, "Hey, does anyone want X?" So feel free at that point in the chat to just type in and be like, "Hey, I want X." So for example, does anyone want a webinar recording? A recording of this webinar? Just say, "I would like a webinar recording." And then we'll go look through those after the chat and then send them to you. We've also got some other good documentation to help you transfer, help you use Git, some good screenshots and whatnot towards the end of the presentation that might be really helpful for y'all. So I'm going to drink a little coffee and get started in about half a minute. And if anyone hears a little bit of clicking, I have a little bit of a fidget toy. I've got a 2x2x1 Rubik's Cube. These things are super fun. They're not as easy to solve as this cube, which webinar starts. They're not as easy to solve as this cube, but they're still kind of fun. So if you hear a little clicking, I'm just doing this to keep concentrating. All right, everyone. Welcome to Allspice's presentation on SVN and Git. We're going to go over a lot of things today. It's really packed. I'm going to have to, unfortunately, a lot of your questions we're going to have to email you back later or set up a video in order to cover them because we have a lot of info. I'm going to cover info on myself. Why am I appropriate to cover this material? We're going to talk about the differences between Git and SVN, some of the pros and cons. We're going to talk about the SVN sunset. SVN, some companies have publicly stated it's going away or they're dropping support. So that's an important thing to keep in mind. We've got some concepts that are in Git that you need to understand or will help you get the most out of the tool. We're going to go over migration, how to migrate your repo from SVN to Git, if that's what you want to do. And we're going to go over an example migration. Going to go over a list of Git clients. And then finally, we have some examples of reviewing and pulling requests, of pull requests and design reviews in Git. So that'll round out your knowledge and help you get started. Give me a second. Oh, excuse me. So who am I? I'm Daniel Lindmark. I'm a hardware and software engineer. I have over 20 years experience developing hardware, done a lot of IoT, worked with NASA. I've helped a lot of companies take low volume production, go from low volume production to high volume production. I've helped companies go from a napkin to their first product and get them successfully ramped up for production. I've worked with Altium, OrCAD, KiCad, Upverter. I've worked with a ton of different ECAD tools. If you've used it, I've probably touched it at least for 10 minutes. I've been using Git for about the last 8 years or so. To manage my hardware projects, and it's really transformed. It really matches our NPI, new product introduction plans, and I liked it so much that when I found out there was a company, Allspice, who was doing Git for hardware, I knew I needed to help them build tools because I was building tools anyways. So just to get started, we're going to go over first topic is Git versus SVN. Look at that. That's SVN on top and Git. Look at those two little rascals fighting it out. So we're going to talk about some Git Pros. One thing I wanted to bring up is one of the biggest differences of Git that people bring up and they feel one way or another is centralized versus decentralized. You may already have an opinion on this based on things that you've done in the past, and you're like, oh no, I know this is the way for me. You may also be like, think that one way is good and be open-minded to hearing some of the changes. But some people are just like, no, I want decentralized, or I want centralized. So what's nice about Git being decentralized is that it operates locally. So you can make changes to the files on your local machine, and it doesn't matter what's happening on the server. You can push your changes immediately, you can push your changes tomorrow. It's really great for teams, who are multiple people on multiple different teams working on the same tools. It also helps avoid a single point of failure. So even if your main server goes down, you can still reconstruct it from any individual, anyone's individual commits. Hopefully you have a server backup, but that may only give you you may have lost a day's worth of work, and you can recover that by using people's distributed repos. I also feel like it's easier to merge multiple authors. Teams have been using distributed teams have been using Git for 15 plus years now. Another positive thing is cherry picking. So in Git, you could take commits from one commit from this branch and 3 commits from that branch, and then create a new branch. And it's a very, very powerful tool, especially with sometimes when you're a developer, you're not always working towards a specific release, so you're making changes, and it may be like the work you did in the middle of the week that needs to go over to a branch rather than all of the work you did that week. Git has some cons. It has a reputation for having a high learning curve, and I think it deserves it. I'm going to say this a bunch of times. Git gives you enough rope to trip over yourself. So when you're just starting out, there are a handful of commands that you can use, or there's some graphical user interface clients that can simplify things tremendously. But if you do want to use the full Git, it does have a pretty high learning curve. I think most users can go from about a 5 to 20 minute training session with some of the easier tools and be able to start using it effectively. So yeah, it takes a while to get deep into the knowledge of the learning curve, but just getting started, I think there's, you can get up to a very serviceable usability. Here's a really important one: is granular access. So people in SVN are used to, atomic commits for files. And the way that you do that in Git, it's not that Git doesn't have granular access, it's that it's handled differently. So you could use something like LFS, large file system, that allows you to lock files. It also has the benefit of helping you out with your large file systems or large files. It's kind of like when you're, if you know anything about web development, your text may be on one server and your images may be on another server, because the images it's just someone has figured out a cheap, easy way of hosting those. And that's the same thing with LFS, is it makes the speed on those files speeds up, and it allows you to have the larger files without bogging down the system. There's also other ways of creating granular access using branch protection. You can create filters based on files. So you could go in and say block a file, and then you would have to unblock the file. It's the same thing as locking and unlocking. There's another con for Git. So this is a multi-dimensional issue about repo size, and it really depends on what types of files you're putting in. Git is fast. Git only sends information. It only sends the delta. So if you've got 300 schematics and you only edit a little bit of a page in one schematic, when you make that commit, it's only going to send over that little bit. It doesn't actually send over the whole file. Where this becomes a problem is if you have a binary file, like a programming image or actual images. Those will tend to as they change, you pretty much have to send the entire file over, and they don't compress very well. So you wind up, your repo size on the server winds up getting, very, very large over time. Like I said, you can use LFS to promote that for the larger files. The trade-off is that it is faster. So just because there's lots of files, if you only want to pull down like the most recent branch or the main branch or a tag or something like that, you'll be able to get it. The size won't affect you because you're not downloading everything. But it is something to consider. especially if you have 20 years worth of SVN repos. Maybe you have maybe your large file size is incredibly large. SVN Pros, we've got centralized repositories. So depending on how you feel, independent of how you feel about it, central repos are easier to understand. We've been doing hub and spoke hierarchy for thousands of years. We get it. People are easy to learn it without learning use it without learning new concepts. SVN is much better. I don't want to say better. It handles SVN large binary files in a way that allows you to save space and just work with them a little bit less awkwardly. It's got a simpler branching metaphor. I think that the trade-off, I really enjoy the advanced branching of Git, and I'm going to show you an example later of branching that is, you wouldn't necessarily be able to do, or it'd be much more difficult to do in SVN. And so I don't see this as much as a limitation, but if you want to keep things incredibly simple, SVN does start off as simple. You can also just have two branches. You could have a development in Git. You could have a development branch and a main branch, and that's about as simple as it gets. SVN Cons talked about central repository. You're going to feel one way or the other about this. This is either going to be a pro or a con. Another one is scalability. It's not necessarily the best choice for very large projects or projects that require a lot of people in different teams, or if you're just working with a couple of PCBs, less of a problem. But if you're a team that has dozens of printed circuit boards that are in production, SVN doesn't scale as well. It's part of it is because of the centralized architecture, and part of it is just the way that files go back, the updates and the transfers. I just feel like the more individual pieces of information you're working on, the more Git lends itself to making things clearer. We already talked about the single point of failure. All right, one thing I wanted to cover, before I go into the slide, that's my picture of my lovely Chicago. I actually can't tell if that's a sunset or a sunrise. I don't know if the picture's from the lake or not, but I think my city's beautiful. So when it comes to SVN, some companies have decided that they're moving on, and some of them are big companies. So, for instance, GitHub, one of the largest Git repository hosts and also SVN hosts, is sunsetting Subversion support next year. And that's because they only get a few thousand submissions of it every day, as opposed to the millions and I don't even know how many submissions GitHub gets. Microsoft purchased GitHub in 2018 for $7.5 billion, so that's a pretty big bet. They've been internally transitioning their teams from SVN to Git. A lot of other big companies in the FANG have also been switching. I think this is one of the biggest tells is the Apache Software Foundation, the maintainers of SVN. They've also been switching a lot of their projects to Git. But maybe you don't care about big tech titans. We've got a lot of customers. A lot of our customers have come to us specifically because they have had issues with SVN. They wanted to improve their process, and switching over to Git allowed them to achieve a lot of their goals and allow them to move forward and produce more and better boards. Let's go over a couple of concepts missing from SVN. So I think it's in the next slide. I'm going to go over an advanced branching example. So instead of having a single trunk, Git has any number of branches. So there's not really one main if you don't want there to be. You can absolutely have a very simple repo where it's just one. Another topic is staging. So this is kind of like a local workspace. So let's say you edit your changes in your schematic, and you want to see what changes you've made before you want to make a commit. This allows you to look at the deltas of the files, allows you to see which files you're going to add. That way you can prevent yourself from making unintended changes. It also, let's say you're making some changes and then you want to go fetch something and see, like, did anyone else update this file? So it allows you to see if there's a conflict before that you actually push the files up. There's also more sophisticated commit objects, so it's got more detail on every single revision of the author, the commit message, the parent commits. I feel it's a lot more easier to navigate the history. Okay, this is the branching strategy I wanted to show you. So this is a timeline or a repo graph. These are drawn right to left. So right is early, newer things, and left is more mature. So as branches are merged in, we merge them right to left. I don't know if my finger's pointing the right way on the camera or not. The other thing to keep in mind in this diagram is the bottom of the graph is the beginning of time, the Big Bang maybe, and then the top of the branch is, or the top of the graph is now. So time moves forward in the up direction. So this is a branching strategy that I use to mimic my new product introduction strategy. A lot of companies have NPI teams, and they have a very specific way that they're going to develop and release boards. So in this example, we start off with, on the far right, we've got feature branches and bug fix branches. Those changes, for example, at the bottom, we're going to replace an I2C mux and then update some passives to update the I2C address. I'll move my mouse down here. Actually, let me see if y'all can see my mouse or not. Yes, I believe you can. So we merge this branch into the development branch. The development branch then accrues any other feature branches that you want to add into it. Then when you're ready with that, you merge those into a prototype branch. And this is the first branch that's going to allow you to release files. It's not quite ready yet because I'm sure you got the silkscreen 100% right the first time, but the contract manufacturer is probably going to come back with some changes. Maybe some components are out, or maybe some components are too close together. Anyway, so in the prototype branch, you then keep on making your changes until it's ready for a prototype. And then after that, you release it to pilot. You manufacture some prototypes, you get the prototypes back, you test them, you debug them, you create bug fixes. Then you wind up including all those changes into the development branch, and then merge it into the pilot branch. Same thing with the pilot branch as the prototype. It's just more money, higher stakes, and also you're not really expecting there to be any errors at this point. And the pilot branch is just to make sure that you have enough to make sure that you're ready for high volume production. So when you spend more money, you're not going to come into a big gotcha. It also helps out the manufacturing team, help them get used to any tests or manufacturing processes that you have, allows you to document those things and incorporate those changes. Then when you're done with that, you make any changes that you need to make and then merge them into the production branch. And at that point, you can send the files over to the PLM system if you have one. You can also use the Git system itself and give your contract manufacturers accounts. And they'll be able to look at the files off of releases. So this is the approach that I like to use. It's 4 stable branches that are there almost all of the time. And then the feature branches come and go as you need to use them. Migration time. So these are all of your files. Each pink one is a file. We got 2 little cuties up here. We're going to go over the migration. So one important thing is, well, many important things is you want to be mindful about your migration. You don't want to just migrate the files with the first script that you find. You want to think about it ahead of time. And so here's some checklists. I didn't write this checklist. This is actually Microsoft's checklist for migrating. So it's a lot of people have followed this. First thing you want to do is sit down with your team and ask and discuss how your workflows are going to be and how things have worked before in the past, how they might want to change in the future. You want to decide which tests are going to be run, and come up with a release management process, something that matches what your business does. And if you need to make modifications, like let's say SVN wasn't, you were doing things in kind of a weird way, maybe now is the time to change those. Then what you want to do is you want to start completing your design reviews, make your pull requests, or move your files into the repo. It's kind of good to lock down your repo after a point. There may be a point where people are working on things and not checking them into the repo because it's just a good cutoff point. You want to think about a Git branching strategy. So, I gave you one earlier. We've got a lot of other really great branching strategies. We've got a document called the Git for Hardware ebook. So if anyone wants a copy of that, just post in chat. I'd like a copy of the Git for Hardware ebook. And let me just back up a couple of slides. I've got like 5 more branching strategies there. I've got a lot of other good best practices. So for the other important thing about the branching strategy is to document why you do it. Everyone may understand today why you do it that way, but maybe someone will come in a month or a year and need a lot of background on it. So the history, you want to decide on your team like how much of the history you want to keep. Maybe you can get away with just getting the most recent branches. Maybe you're a young company and you don't have that many files. But if you do have 15, 20 years of SVN files, you may not want to bring them all over, and you may not be able to bring them over in the same way. You may have 10 years ago done it one way, and then 5 years ago made a change. So you may have to wind up migrating your repos over in chunks. The other thing you want to do is create breadcrumbs and ways so that engineers and system admins can go back to your SVN repos. It's always a good idea to keep a backup and then some sort of way of accessing them afterwards. Something that's not too complicated, so they don't have to spend a couple hours, doing it each time. And hopefully, you only need to go back and get an old file once a year or so. Another thing you want to do is look at your binaries and large files, and do you want to move all the history of the files? Do you want to just move the most recent version of them? Do you want to use Git LFS? So think about that. And then you want to have training. So just because everyone sat and talked about it doesn't mean they're experts yet. So you want to find the training material. You want to plan events. Hosting people in a room. Or a web chat where people can log onto their own computers and move through an example design commit push process is really helpful. And then this is like one of the most important parts is file migration. You don't ever want to run the scripts as is on the actual source material. You always want to make a copy of your repos and then work from that. And then, do multiple tests to make sure it's going to go smoothly. I've run a migration twice in a row, and, it winds up changing some of the settings in your system, and it won't work the same way the second time. So you may migrate one folder, and then you move over to another folder, and then something's not working. So that's really important. It's important to communicate the cutoff time, like when the repo is going to stop, so everyone's on the same page. Create the new Git repo, set the old system to read only, so that no one can commit changes. I would also recommend for each of the migrations is start with the main branch first. Make sure that works, then move over the other needed branches. So get a known good Git repo and then move everything over. I'm gonna take a little coffee break. Excuse me. For the migration workflow, I recommend preparing a migration environment. It might be a special computer. You may want to do it on your desktop. Maybe you want to do it on a server. You're going to convert the source SVN to a local Git repo, which we'll go over. You're going to synchronize the local Git repo with any other changes that the SVN repo made. So if you can't, if people are still developing while you're cutting over, you're going to have an approach to merge those changes in, and this is when you do it. You push the local Git repo to a remote repo. It's not really a development system if it's just on one computer. And then lock the SVN repo, synchronize any remaining changes, so people won't be able to add files anymore. And then finally, switch over to Git as your main source control system. So let's go over some of the gritty details. So this is a lot of details in here. Some of y'all came in after I started, so I just wanted to say, if anyone wants a copy of this presentation, just say in chat, I would like a copy of the presentation. There's going to be a lot of commands coming through here, and I'll pause, but I don't expect you to copy them, verbatim or take screenshots. You should be able to just roll through the presentation afterwards. So there's simple migrations. If you have a brand new repo, if you started it a week ago, if you have no changes, those are really easy. If you have a standard setup of trunk, branches, and tags, it's relatively easy. But where SVN migration becomes a problem is when you have many branches, you've got a lot of different complex merges, you have a non-standard directory setup. Or worse, well, I don't want to say worse, it changed over time. So like I said, you may have a section of time 5 years ago and before where it's, you're going to have to write a different script. So you may have to write scripts to specify revisions and then move things over in chunks. And like I said, test it first. We've got our documentation on how to migrate is on our knowledge base. It's allspice.document360.io. You can also get there from our main website, allspice.io, and then I'll tell you how to migrate an SVN repo. There's also a couple of other good tutorials. There's Microsoft has one, Git Kraken, and Git SCM itself has one. What I recommend for you is to read more than one. Don't just read the first tutorial or the first set of commands you see. Your journey is going to be different than these. These are good starting points, but your files aren't going to be exactly the same. And it's important to see the different ways that the different tutorials show you, so you can get an idea of what works for you. When you do prepare your environment, you pretty much only need two things. You need Git and SVN. And when you install Git, you should also get a utility called Git SVN. All right. So one of the things that SVN does differently is it keeps its authors set in a different way. So a command like this lets you generate an authors file, and it allows you to transform, when you're creating your repo, more detailed information on the authors. So I've got a line here. This is me. This is what it would look like generated. And then this next line is what you would do to add information in from like email address or maybe a full name. So, generate the file, open it up, and then make some manual edits, or maybe you have a script that lets you do that as well. So the next thing you want to do is you want to clone the repo using Git SVN. Here's the command here. We're using, in this one, we're using the standard layout parameter right here. So that's when the trunk and the branches and the tag are all the way you expect them to be. If you have different trunks, if your trunk is a different name, or it's in a different location, or your branches are different, this is where you would set that up. Then you grab a snack. Migration can take seconds. If you have small files, it can take hours. Or if you have decades of files, it might take days. So this is the other part of planning accordingly, is you want to have it on a system that has good enough resources, but also that you're not time bound, that you have the time to run the process several times. So you also want to convert. So SVN has something called SBNignore. These are files that you're not going to check in. Allspice, or not Allspice, Git has gitignore. And that file is basically a list. It's a list of patterns of files not to catch, or files that you're not going to add into the repository. If you don't know what to use for those, like if you haven't been using SVNignore, I highly recommend grabbing an existing gitignore file. It doesn't matter what CAD program you're using. Someone has written one for it. I've got 3 of them right here. We've got one for Altium, KiCad, and Eagle. So these will hide the files that aren't important and aren't really part of your design. The next thing we're going to do is push a bare repo to a Git repo. I'm not going to go over all of these, but the first one creates a new repo, and then it's bare, meaning there's nothing in there. You then link the trunk, so that lets you link your symbolic head over to the SVN. Next thing you're going to do is push the local repo to the new bare repo. So you migrated it, but now you want to move it over to this better formatted repo. And then you rename the trunk branch to main. The next step you're going to want to do is migrate your tags. So these are, versions of your code or of your designs, like Rev 1, Rev 2, Rev 1.1. And again, don't copy this verbatim. Read the documentation on this. Make sure it's doing what you want it to do, what you think it's doing. Make sure that you create all of your SVN branches as proper Git branches. Again, here's a command that lets you roll through those. Should every release branch be migrated? Can some feature branches be waited until after migration? You may not want to move everything now. You may want to do a partial move now, and 6 months later, move the rest. Maybe you need to move stuff that's work in progress. If you want to migrate only specific revisions, there's a lot of commands for that. I don't remember if this gives you the most recent 100 or the first 100 revisions, but you can use options like -R to get a specific set of revisions. You can also run the command multiple times and move over a little bit from the beginning, a little bit from the middle, a little bit from the end. Another thing you can do, or the next thing you want to do, is push your Git server to your local Git repo to a remote server. I've shown here the text way of doing it from the command line, but you can also use this Tortoise Git. It's a really wonderful program. You can do a lot of things automatically, just from a graphical user interface. So now I'm going to give you a migration demo. I did a pre-recording of this because I have fat fingers and poor eyesight, so it's a bad recipe for a webinar. So this is, let's start. Gotta move back. So let me start from scratch. We've got a project here called Archimager 5000. It's a 3D printer control board, so it's got motor drivers on it, some sensors. And this is a SVN project. So in Windows, I like to use Tortoise Git or Tortoise SVN. Those allow a lot of in-place manipulation of files. It allows you to commit and push, and pretty much any command you would do either in SVN or Git, you could do it graphically here. So in this one, we're going to browse the repo using Tortoise SVN. And you can see here that here's all the files for the project. We have PCB files. We've got schematic files. We're going to copy this URL of the project, the file location, basically. Going to go to another folder, right-click again, and then instead of Tortoise SVN, we're going to use Tortoise Git. We're going to click Clone. Now make sure that these are correct because it's pretty easy to get the folders wrong. So we put the source URL that we grabbed from SVN. And then we're going to click from SVN repository. For this example, I'm showing you a really simple one. So I'm going to uncheck the trunk, tags, and branches. I'm going to run OK. We're going to get our coffee. I get my coffee break again. Look at this. We're going to go through 19 revisions of files. Okay. I got a note saying it's still on the same slide. Are people not seeing the video right now? I mean, I paused the video. Here, you should see a video right now. Sorry, I'm looking at chat right now. Oh, well, for some reason, I'm not showing you the video. Okay, well, anyone who wants to see the recording of the video of the of the migration, please raise your hand and say I'd like a recording, and we'll send that separately. I'm not sure why it worked in during the tech demo. So do people now see a slide that says Git clients? Oh, someone saw the video. Huh. Well, I'm going to go forward and talk to the Git clients. So when you're using Git, there's a lot of different ways to interface with it. One of them ways is Git bash or from the command line. This is where all of your power users use the code. This is where advanced configurations can be set. If you've heard about the learning curve of Git being difficult, this is one of the reasons why. So I really only recommend this to people who either limit the amount, or either really good with Git, or limit the amount of commands that they use, because it is relatively easy to mess up a project this way. There's also a couple of great great tools like GitHub Desktop. I think that this one is the easiest to use. It has very limited functionality, so it's a lot harder to hurt yourself with your repos. We've got a couple that have really great graph commits. So you can see here, Git Kraken has a very stylized and attractive looking graph. It makes it easy to understand and resolve issues. There's also Git Ahead, which I believe is free, but not open source. I'm not sure about that, but it also has a relatively easy to understand graph. The crowd favorite among software developers is Sourcetree. I think the most people use Sourcetree worldwide for Git. But for our purposes and designs, a lot of electrical engineers wind up using Tortoise Git because it's very similar to Tortoise SVN. If you're already using Tortoise SVN, I don't want to say it's a no-brainer, but it's a pretty good first tool for that. There's many, many more. There's dozens of other GUIs out there. I recommend going to this URL to check out the rest. So Git hosting. So there's multiple places where you can get your Git code hosted. You could host it yourself. I highly recommend having managed hosting, having someone run it for you. We've got, I'm sure everyone's heard of GitHub and GitLab. There's also support for hosting for companies like AWS. Like, let's say you have an Amazon design stack, you could do it that way. Or if you have a Microsoft design stack, you could use Azure DevOps. All right, design review demo. So I'm going to bring in another screen here. So after you get your files into Allspice, I kind of want to show you what it's like using the tool into a Git repo. So let me duplicate this tab. So this is a repo. This is in our tool Allspice. It should look very similar to GitHub if you've seen it before. Here's a list of all the files. You can see the commit messages here, and it's specific to each file here. So the last time endstops was updated, it says remove that extra endstop channel. Another thing that you could do is you can look at the specific commits, and you can click on any individual commit. Here, remove channel from MOSFETs. Let's look at that. And we can see here that we did indeed remove this channel. So changes here are in red. I'm sorry, removals are in red. Let's go to a design review. So let's say you want to make your changes. Someone's pushed some changes to a branch and they want to show their designs. You want to show your designs to your teammates so you can get a review on it. You create what's called a design review, or more commonly referred to in Git as a pull request, a PR. And in that, you can have conversation about it. So for instance, you can put in pictures in here. You can put in screenshots of what changed. If you want to talk about BOM changes, you could do that. We also have a pretty robust template checklist. So you can, by default, load up this list. And then when you're done, you can wind up checking off the review parts so that you can know that it's actually been reviewed. To the right, we have a list of reviewers. You can see here that Johnny5, we're re-requesting a review for them because they said they didn't like it, which is good. Next, we're going to look at the files changed. So this particular design review only has 3 files, but you could have dozens of files if you wanted to. For the schematic view, or sorry, for the PCB view, we've got this layer view. So you can select none, say top copper, top layer. We're going to look at the power plane in the middle. Let's look at the bottom layer. So each of these layers you're able to select individually, or multiple layers. You can put them all on top of each other. You can zoom. Let me put all the layers back on. You can show the full diff. You can show what's just been added or changed. You can show what's been deleted. I'm going to show you zoom here. So you're able to pan and zoom. Another useful feature is it's always a resistor in design, right? Let's look at R90. Look at that. Pan and zoom. I think let's also do, I don't know, user U21. I like the number 21. There we go. So it allows you to navigate and look at individual parts. You can also click on components. I'm not sure I clicked on that one, but it's U6. Yeah, I clicked on U6. U6, it's a quad differential comparator. You can believe the part number's in there somewhere. Next on this is we have a CSV view. Oh, I minimized it. We have this feature here where when you're done looking at a file, you can click view and then it minimizes it. So here at the Archimajor demo, here in this Archimajor.csv, we've got a red line. So this was the old reference designator. These are the new ones. You can see that we went from quantity 11 to quantity 19. Makes it really easy to read. Finally, we've got a schematic view. So you can see here we've changed these nets. So we either renamed the net or changed some of the properties on all of them. But then we also added, you see in green here, we added these protection diodes. So the other thing you'll see here is lots of little comments with like these pictures here. These are called snippets. So let me zoom out. Actually, no. Let's do this again. Do U21. And then I'm going to create a snippet here. And I'm going to say, click on this. And then this is going to automatically jump me down to a comment here. And click on preview so you can see the actual image here. And then I'm going to say at Johnny5, please check stock of these components. And Johnny's going to be more than happy to do that. So if Johnny has notifications turned on, he'll be getting emails or notifications up on the top of the tool. And also when you check in here, for example, I've got design reviews here. Here's a list of all my open design reviews. So I'd be able to see right here things that people have asked me to do. All right, I think that's a pretty good design review demo. So this is basically you make your changes on a local machine. You push them using a Git client, like let's say GitHub Desktop. And then once those changes are in here in the system, they show up as commits. And then the commits, you merge from one branch to another using a design review. So for example, we are merging one commit from the develop branch to the main branch. Okay. I just want to tell you a couple other things about Allspice. When you click, oh yeah, actually, I think I missed that. Wanted to cover this in the schematics. So each of these components has all the details in them, just like on the PCB. So you can see things like the manufacturing part number. You can see the manufacturer. So this is Diodes Inc. Great manufacturer of diodes. So you're able to click on everything and get a detailed view of it. If you change a parameter in here, you'll also see a delta inside the comparison. So I don't think this is going to work because it's been deleted. I don't think you're going to see anything but a red line. Yeah. So let's jump back. So about Allspice, you know, we've created a tool that works with Git on top of Git. So you can move your files in here, and then you're able to see representations of your schematics, of your PCBs. You can see object level views of the sheets. You know, so like I said, you can click on an actual component, get details from it. We also have upcoming a CI and CD continuous integration, continuous deployment system. So this will allow you to run Python code. It'll allow you to run triggers after, you know, after you commit, or after you commit or branch or create a release. We also have a really powerful REST API with Swagger. So let me show you that real quick. At the bottom of any Allspice page, you're going to see a list of the API, a link to the API. You click here to set your authorization token, you know, to get your security in. And then each of these commands here are, you can wind up opening it up. So you can take a look at the repo. You know, you can get all the branches. Pretty much anything that you can do manually, you're able to do using an API command. So not only do we have the API commands here with full documentation, you can also try them out. I'm not logged in right now, so if anyone wants a specific demo of the APIs, please raise your hand and we could set something up like that up. And I would say the gist of what Allspice does is we automate repetitive, low-value, and error-prone tasks. We're DevOps for hardware. We help people who already know how to design great hardware build a process around their tools so that they don't have to worry, you know, they can focus on designing rather than focus on the tools. If you do want to learn more about Allspice, you know, we've got a knowledge base. I put the link in an earlier slide. You can also get there from our main webpage. We've got a lot of how-to guides, a lot of getting started. What's nice about our documentation and documentation on Git in general is you don't have to use our documentation or our tool because Git is an open tool. Anyone can give you information on how to best use the tool. So you're not locked in with us if you wind up using us. We're happy to support, provide as much support as possible. But you know, if you want to, your data is portable. If you need help with us, you know, you could reach us at support@allspice.io. We'll get back to you. We are running low on time, so I would like, if someone has a question, please take the time to type it in now, but we're probably not going to be able to get back to it in time. I am going to try to run that video one more time because someone said that they could see it. So I'm going to at least jump to the second half of the video. And then here we go. So I hope y'all can see this. If you're seeing the previous screen, I'm sorry. So this is, let me jump back. So here's cloning using the web command from before. I'm going to close that. Okay. I'm going to open up this folder just to show you. Here's all the files that we've migrated. You're able to edit them and use them right now. But before we do that, what we're going to want to do is, so I've got an existing, I created a repo using the web interface, and this is the address. We're now associating this address so the repo knows how to talk to it. It's basically saying like, hey, you're the origin. The origin is this URL. Then I got fat fingers. Let's type a couple of things. All right, so next what we're going to do is we're going to push. We're once again saying that the alias is the origin. We're going to push to the main branch. And there we go. So this is a typical Git message. It's showing you, it's writing the objects. And we could see that we pushed everything here to main. So this is the repo that I wound up creating. This is before the push shows up. I'm going to hit refresh. There's all the files. So you can click in here. This is the same PCB that we were looking at a minute ago. I think that should catch us up with the demo. So Robert, can you reiterate your ask so I could tell the chat? Okay. So to see the entire, we just dropped a link in the chat. So to see the entire platform live, you can schedule a tour, a demo. Our sales executive, Ali, will be more than happy to show you that. So the other things I think we asked for was a Get for Hardware ebook. So if anyone wants that, raise your hand and type Get for Hardware ebook or a copy of this presentation. I'm just making sure the links are correct. Yeah, don't use this demo. Use the demo that's in the chat. Well, I wanted to thank everyone who came here, especially y'all who had questions. If you do wind up having, thinking Git is right for you and you want help migrating, we offer migration assistance for companies that are signing up for our service. There's practice. It does take a while to migrate. There's a lot of wrong ways to do it. So just make sure you keep a sober head and, move in little steps. Other than that, another thing that we have here is if you wanted a trial for Allspice, we're offering a coupon. So there's a promo code in chat. So if you are ready to sign up, please feel free to do that. Other than that, it's been really great talking with y'all. I look forward to hearing more, with email and chat. But thank you very much. I think it's off. Is it off?